Okay, let's get started with section 6.4, and we're going to split this up into two parts, an A and a B. So this is 6.4a, and so we'll introduce logarithmic functions here. So what the heck is a logarithmic function? So we'll shorten them up and call them logarithms for the rest of the time here. Sometimes we'll say them by the formal name, logarithmic functions. But really all they are, and we'll go through the whole definition here, but all they are is we're trying to figure out the power, all right? Figuring out the power is what we're looking for. So if we have y equals log base a of x, that's going to say, all right, if we have a base of a and we're trying to get to x, what is the power? All right, the power is what we're solving for. All right, so we'll talk about this a bunch here with some examples, but one thing to note down for sure, the domain of logarithmic functions, the parent log function is x is greater than 0. All right, we're going to start with that. All right, so let's relate logarithms to exponents. So if y equals log base 3 of x, then x equals 3 to the y. Now, notice here, we just got done with exponential functions. The exponential function would have been y equals 3 to the x, which, as we know, looks like this. Right? It has an asymptote at y equals 0. It crosses at 0, 1, and it would have a point at 1, 3. If we switch this, we find the inverse, and we do x equals 3 to the y, right? Which is log base 3 of x equals y. Then, instead of an asymptote y equals 0, we're going to have an asymptote x equals 0. Instead of crossing at 0, 1, we're going to cross at 1, 0. And instead of touching 1, 3, we would touch 3, 1. So it would start hugging the asymptote here and then flatten out as we got bigger x values. All right, let's take a look at another one. If we had log base 3 of 81, it would have to equal 4 because 3 to the 4th is 81. So again, this is your base, this is your power, this is the solution, the whole exponent. All right? Okay, so one more example here. That kind of got messy there, but if we have log base 5 ending up with y, that would be 5 to the y equals x. I don't know what's going on with the computer, but we've got all sorts of things on here. There we go. That's a little cleaner. Sorry about that. All right, last one there. Log base 5 of 1/5 should equal -1, because if we rewrote this, this would be 5 to the -1 equals 1/5. All right, so if you get stuck with logs, you can always rewrite them. All right, so let's do that right now. See if we can change exponential expressions into logarithmic expressions and the other way around. So rewriting 5 to the 8th equals t. So what's going to be by itself? Okay, in this one, we're trying to find the power. So 8 equals log base 5 of t. -2 equals log base x of 12. X equals log e, which actually has a special name, which we'll talk about later, of 10. All right, knowing that, try problem 9. Okay, let's go the other way with this. Can we take logs and turn them into exponential expressions? 2 to the y equals 21. Base 2 to the y. Base z to the 6th equals 12. Base 2 to the a equals 10. All right, so remember, this is always going to be the power. We're trying to solve for the power. How do we go from 2 and get 10 using an exponent? Try problem 17. Okay, objective number 2, let's evaluate some logarithmic expressions. So we'll start with some straightforward ones that you can do without the calculator. You need to ask yourself, 3 to what power equals 81? And we could, if you didn't see this, we could break this down. 81 is 3 to the 4th. Learning the skills we had in the last section, we can cancel our bases and say x equals 4. Same thing here. 2 to what power is going to give me 1/8? 1/8 is 2 to the negative third. X equals negative 3. You're up. Try problem 25. All right, objective 3. This will be the last objective of this section here. Determine the domain of a logarithmic function. Okay, we talked earlier about logs being the inverse of exponential functions. So remember, the domain of exponential functions was all real. So we know that the range of logs is all real. We knew that the range of the exponential was y is greater than 0. So the domain of log functions is x is greater than 0. All right, and so that's written out there as well. Let's find the domain of each log function. Okay, so I'm going to throw the graphs up on the graphing calculator here in a second, but this first one, A, I think we could be able to do just with looking at it, because we know the domain of the parent function should be x is greater than 0. What's happening here? We're shifting to the right by 2, so the domain here should be x is greater than 2. Let's take a look at the graph and confirm this. Okay, so I've written in the rest. I haven't written in this first one because I want to show you how to get the logs on here. So, on your graphing calculator, hit the math key. You're going to go down all the way to A, log base, hit enter, and it's got 2 fill in the blanks for you. So, the first one, the base is 3. Raised to the power of x minus 2. So log base 3 of x minus 2. Okay, let's go ahead and graph it. Notice that I've turned these other graphs off. I just want to graph this first one. And if we see here, it looks right. We're only to the right of 2. If we really wanted to convert this, we could check our table. If we started at 0 and counted by 0.1, let's start at 1.5 just to save ourselves some time. So starting at an x value of 1.5 and counting by 0.1. So can't have 1.5, can't have 1.6, can't have 2. We could be 2.1. So 2 is our asymptote. Right? That's the last value that we can't have. So x has to be greater than 2. If we're greater than 2 in x, we have values for y. All right, so let's go back in and check the rest of these here. So we're going to take a look at this one. This is a rational function. We know the shape of that should be quadrants 1 and 3. Let's go ahead and graph it. So for a lot of these more complex ones, at first you're going to want to graph them. So I've already typed this in here. And take a look. Let's see what we've got here. Something went wrong. Probably lost a parentheses here. Log base 2 of x plus 3 over, there it is. Made the same mistake that I'm always telling you not to make. Check your parentheses. X minus 1 needs to be in parentheses. And then our final parentheses there. Let's try that one more time. There we go. Should have the curve in quadrants 1 and 3. But since it's a log problem, it's cut off. X has an asymptote. There's an asymptote at x equals 1 and at x equals negative 3. I think we could have figured those numbers out without graphing if we were clever. So the domain is going to be x is greater than 1 or less than negative 3. Let's take a look at the third one here. I'll go back in here and turn the second graph off. Turn the third graph on. So log base 2 of x minus 1. Remember, absolute value is going to make a v. So we're still going to get that, but it's going to be slightly changed here. Okay. All right, so the only question is, can our value be at 1? Otherwise, it's going to be all real. Let's take a look at the table to see if we can have an x value of 1. Nope, we cannot have an x value of 1. All right, so you want to check that middle value there. So the domain of this would be x does not equal 1. It could be anything else, but x cannot equal 1. All right, last one before you try them on your own. Y equals log base 1/2 of x squared. go ahead and graph this. And it's going to look like that. And so the only question is, can x equal 0? Let's take a look at our table to find out. And it cannot. So x does not equal 0 for this function. All right, so use your graphing calculators, help you out on 39 and 45, and that will do it. Any questions, make sure we're asking them in class. Good luck on those problems.